Hi, this is Kyle. I'm with ServoCity, and today I'm going to talk to you about the general operation of servos. Today I've selected a HS485HB servo. It's an analog servo, standard size. No matter what servo it is, you're going to find three wires coming out of it. You've got a negative, a positive, plus we have a third wire, which carries a signal generated from the servo controller. No matter whether that servo controller is a transmitter and receiver, if you're running wirelessly, a servo programmer, such as the HFP25, or the dual servo driver, which is a wired controller. What I would like to do is plug a servo into the servo programmer and show you how it operates given a varied pulse width modulation signal. A pulse width modulation signal is a square wave signal, and the period on that is typically 20 milliseconds. As you increase the signal in a high-tech servo, the servo rotates clockwise. As you decrease that signal, the servo rotates counterclockwise. Typical range on a servo controller is about 1050 to 1950 microseconds. With that signal range, you'll see that a servo rotates about 90 degrees. If you have an analog servo like this 485HB, and you can transmit a wider signal range, say if you're running an Arduino board, then you can get a lot more rotation. If you send a 600 to 2400 signal on the 485, it's going to rotate about 180 degrees. If your servo controller is not able to send a wider signal in order to get that 180 degrees, then you can pick up a Servo Stretcher from ServoCity. It's a little module that modifies the signal before it gets to the servo in order to increase the rotation. Now, if I were using a digital servo instead of the 485 analog, which I'm going to go ahead and plug in the HS5485HB, which is the digital equivalent to the 485, you'll notice that it rotates about the same amount as the 485 on this servo programmer. With the digital servo, you can't increase the rotation by increasing the PWM range beyond about 850 to 2150 microseconds. If you need more rotation out of your high-tech digital servo, you're going to have to reprogram it. You can pick up a high-tech programmer, such as this HFP25, and we offer several others online as well. If you're not comfortable programming your servo, then we also offer that service here at ServoCity. What a lot of people don't understand is how a servo is actually going to operate on different servo controllers. So for example, I've got a wireless radio system consisting of a transmitter and a receiver. I'm going to show you how it operates. As you move the joystick to the right, the servo goes to the right. As you move it to the left, it goes to the left. When you release it, it's always going to go back to center. The reason the servo returns to center whenever you release the joystick is because the transmitter is sending a 1500 microsecond signal, which is the center position of the servo, whenever the joystick is in the center position. Now, if I were to use the dual servo driver over here instead of a wireless radio system, then the servo is going to operate a little bit differently. With the dual servo driver, you can adjust the pulse width modulation signal going to the servo by rotating the knob. And as you rotate the knob, the servo is going to mimic that rotation. But when you release the knob, because it doesn't return to center, the servo will also stay in position. In the hobby servo industry, there are two main types of servos. You have analog servos and digital servos. And although they may appear almost exactly the same, there are a few slight differences. The digital servo is able to take the signal received from the servo controller and respond a little bit quicker than its analog equivalent. It also has more holding torque when it gets in a position, so if you put a load on it, it's going to be harder to deflect the horn. They have more torque in general. They have some programmable features. They do make a little bit more noise than the analog equivalents do. So there you have it. You have the basics on how servos operate, whether it's a digital or analog, and whether you're using a wireless radio system with a joystick or a servo controller with knobs. We here at ServoCity look forward to helping you with all your servo needs. So if you still have questions, be sure to pick up the phone and call us, or you can email me at tech@servocity.com.